Welcome back to Josh Does Math. In this video, we're going to be doing a problem related to the tangent and the normal to a curve. And our curve is right here. Y equals 6 all over x plus 2. So that curve is going to look something like the graph of y equals 1 over x, but it's going to be shifted and stretched a little bit. So we'll just say it looks something like this. And we're looking for the tangent and the normal to the curve at 1, 2. So let's just say this is 1, 2, somewhere out here. We're going to be looking for the equation of the tangent at that point, and also for the normal at that point. Now the normal is just perpendicular to the tangent. So the normal will be something like that. So we're looking for those two equations, and we'll start with the tangent because that's a little bit easier. So for the equation of the tangent, we know that the tangent has the same slope as the curve at that point. So what is the equation? What is the slope of the graph at that point? Well, we can take the derivative of the graph and we can figure out what the derivative is equal to at 1, 2, and that'll be our slope of our tangent line. So we're going to take dy dx, so that's going to be d6 over x plus 2 dx. So this is just a quotient rule problem. So quotient rule says derivative of the top times bottom minus derivative of the bottom times top all over bottom squared. And this simplifies a little bit more. So we get 0 minus 6, so that's negative 6, all over x plus 2 squared. So that's what our slope is equal to. Now, what is dy dx at x is equal to 1? That's going to be our point right here when x is equal to 1. Well, we just plug in 1 for every x in our derivative formula right here. And we get negative 6 over 3 squared, which is just negative 6 over 9, or negative 2 over 3. So that is going to be the slope of our tangent line. And we know the tangent line slope, and we know a point that the tangent goes through 1, 2. So we know a point and we know the slope. So we can use point slope form to figure out what the equation of the line is. So I'm going to say y minus 2 is equal to m x minus 1. So I just plugged in for y2, I'm putting y, and for x2, I'm putting x, just general coordinates. And for y1 and y2, for y1 and x1, I'm putting in the x and y that I'm given right here. And now I just solve this and get it into slope-intercept form, and I get, for m, I'm putting in negative 2/3. And now this simplifies as y is equal to negative 2x over 3 plus, this is going to end up being 8 over 3. So that's the equation of the tangent. So how do I find the equation of the normal? Well, I know that the normal is perpendicular to the tangent, and it also goes through that point, 1, 2. So if it's perpendicular to the tangent, we know it has the opposite reciprocal slope of the tangent. In other words, I flip the sign and flip the fraction. So the sign becomes positive, and the fraction becomes 3 over 2. So m is going to be equal to 3 over 2. So this is now the slope for the normal line that is perpendicular to your tangent line. So how can we find the equation of the normal line? Well, same thing as we did with the tangent. We know a point that it goes through, and we know the slope. So we use point slope form. So in the same way, I'll say y minus 2 is equal to m x minus 1. And for m, I'm putting in 3 over 2. So I get y is equal to 3 over 2x minus 3 over 2 plus 2. So this becomes y is equal to 3x over 2 minus, this is like saying 4 over 2. So this is going to become 1 over 2, negative 1 over 2. or positive 1 over 2. And this is the equation for the normal line. So we'll say normal. So those are the two equations of the line that we're asked to find here. And all we did was take the derivative and plug in some numbers, and that's it. Thanks for watching.